Good day everyone, welcome to our class in Construction Materials and Testing CE313. So for today, we are going to discuss one of the most popular construction materials, which is the cement. So let's start. A cement is a binder, a substance used for construction that sets, hardens, and adheres to other materials to bind them together. Cement is seldom used on its own, but rather to bind sand and gravel, which are the aggregates, together. Cement mixed with fine aggregates produces mortar for masonry, or with sand and gravel to produce concrete. Cement has 8 main components. These are the following. So first is the calcium oxide or quicklime, which has 60 to 65%, silica 17 to 25%, aluminum oxide 3 to 8%, magnesium oxide 1 to 3%, ferrous oxide 0.5 to 6%, calcium sulfate 0.1 to 0.5%, sulfur trioxide 1 to 3%, and alkaline, which is 0 to 1%. Almost every construction work requires cement. Therefore, composition or ingredients of cement is a matter of great interest for engineers. Each ingredient has different functions by altering the amount of an ingredient during cement production. One can achieve a desired cement quality. For instance, the lime. Deficiency in lime reduces the strength of cement. Also, it causes cement to set quickly. Silica also imparts strength to cement. Alumina imparts quick setting properly to the cement, and excessive alumina weakens the cement. Iron oxide imparts color to the cement. Also, at a very high temperature, it imparts into chemical reaction with calcium and aluminum to form tricalcium aluminoferrite, which imparts hardness and strength to the cement. Now, let's watch how cement are made.
Cement is one of the materials that has contributed the most to the progress of mankind in terms of economic and social development. Bridges, roads, hospitals, dams, wastewater treatment systems, and many other types of construction would not be feasible without cement and its main derivative, concrete, which have all helped improve the quality of life. The cement process begins with the mining of limestone, marl, and clay in quarries. These large blocks are crushed, ground, and mixed with other minerals. The mix is conveyed into the kiln at temperatures approaching 2000 Celsius degrees, where it is transformed into small granules known as clinker. The clinker is ground with gypsum to become a fine powder known as cement.
So, cement are made from limestone that is processed from a cement plant. Here in Luzon, particularly in Sison, Pangasinan, we have the Northern Cement Plant. When you are traveling north, so makikita ninyo yung bundok ng limestone na kinukwari nila kasi tanaw yon mula sa highway. Sa Ilocos Sur naman, may Holcim plant. In Bulacan, we have the Eagle Cement Plant, Lafarge, and Holcim also. When you become a civil engineer, you can also work on this plant. Pwedeng sa maintenance ng mga structures or managing the quarry activities. Cements used in construction can be characterized as being either hydraulic or non-hydraulic, depending upon the ability of the cement to set in the presence of water. Non-hydraulic cement will not set in wet conditions or underwater. Rather, it sets as it dries and reacts with carbon dioxide in the air. It can be attacked by some aggressive chemicals after setting. Non-hydraulic cement are created using materials such as non-hydraulic lime and gypsum plasters, and oxychloride. After non-hydraulic cement is utilized in construction, it must be kept dry in order to gain strength and hold the structure. When non-hydraulic cement is used in mortar, those mortar can set only by drying out and therefore gain strength very slow. Due to the difficulties associated with waiting long period for setting and drying, non-hydraulic cement is seldomly used or utilized in this modern time. We also have the hydraulic cement. This is also the Portland cement. So this set and become adhesive due to a chemical reaction between the dry ingredients and water. The chemical reaction results in mineral hydrates that are not very water soluble and so are quite durable in water and safe from chemical attack. So now let's discuss the Portland cement. So through experiment, experience, and practice, man has made Portland cement by blending materials such as calcium, alumina, iron, and silica. Portland cement is made by mixing substances containing calcium carbonate such as chalk or limestone with substances containing silica, alumina, and iron oxide such as a clay or shale. An important principle to remember about the cement making process is the dehydration or draining out. So, draining out of the materials by using intense heat. When the cement is later mixed with water, the process reverses the hydration, so that is combining the water, and the cement water paste will become hard as rock. Portland cement is by far the most common type of cement in general use around the world. As designated by the ASTM, there are 5 types of Portland cement. So the 5 types of Portland cement are standardized in the United States by the American Society for Testing and Materials, ASTM. So we have the ordinary, type 1, modified, type 2, high early strength, type 3, low heat, which is type 4, and sulfate resistant, which is type 5. So type 1 and type 1A, so these are suitable for general uses such as pavement, sidewalks, buildings, bridges, tanks, water pipes, and etc. So for type 2, type 2A, so these are used when the acid or sulfate content of the groundwater or soil is higher than the normal. It generates heat of hydration at a slower rate than type 1. This type 2A are used in large piers, heavy abutments, and retaining walls. For type 3A, so these gain strength faster and develop more heat of hydration than the other Portland cements. Using this type of cement, you can immediately strip the forms and use them again. Also, you can use this cement when you need to put the concrete into service faster than the normal. In addition, you can also use this in cold weather to reduce the protection needed. For type 4, so this type has low heat hydration. It is used in massive construction or structure such as large dam where the temperature rise during hardening may cause serious problem. And lastly, for type 5, so these are used where solids or groundwater have a high sulfate or acid content. So when the structure is for coal mine drainage, type 5 of Portland cement is best to utilize. Now let's discuss the various uses of cement. So first, as a mortar. Cement mortar is like a paste, which is prepared by adding certain quantity of water to cement and sand mixture. We know cement has good binding properties, while there are other binding materials are also available, but cement is mostly used because of its high strength and water-resisting properties. It is used to create strong bond between bricks, stones in a masonry. Plastering. Plastering is done by cement mortar, which gives smooth finish to the structure. Cement molds of different shapes can be made using cement mortar. It is also used to seal the joints of brickwork and stonework or cracks. So generally, the cement-sand ratio in a mortar is between 1:2 to 1:6. So the ratio of cement and sand mix is decided based on the importance of work. So next is cement is used in concrete. Cement concrete is a major building material in the world, which is widely used because of its marvelous structural properties. The ingredients of cement concrete are cement, fine aggregate, coarse aggregate, and water respectively. In general, ordinary Portland cement is used to prepare concrete, but for special cases or based on different circumstances, many types of cement like rapid hardening cement, high alumina cement, etc. are discovered. So, yun yung diniscuss natin kanina ng mga types ng cement. Another one for the uses of cement is to build fireproof or heat-proof structures. So, to withstand against high temperature and to prevent fire accidents, structures should be built with great fire-resistant materials like cement. High alumina cement is more suitable material to make concrete for the structures in high temperature regions. So that is for type 5 na cement, na Portland cement. So next, we use cement to build hydrographic structures. So most of the hydrographic structures in the world are built using concrete with cement as binding materials. The structures built in water or in contact with water should be very strong against moisture and they should be watertight. Many types of cement like hydrophobic cement, expanding cement, pozzolana cement, quick-setting cement, etc. are most suitable for constructing water-retaining structures. Quick-setting cement is very much useful in this case when there is a limited time to construct underwater structures. Another is to build chemical-proof structures. In chemical industries, different chemicals are stored and they may be damaged the structure if proper resistance is not there. Acid-resistant cement is very much useful in this case. Similarly, for construction under marine conditions, sewage-carrying structures, etc., sulfate-resistant cement is useful. Next is for grouting. So this is very common. Grouting is the process of filling cracks, joints, opening in the foundations, or any other structural members to improve their strength. In general, ordinary Portland cement is used as grout material to which required amount of water and sand is added. To fill very fine cracks or to fill deep, thin cracks, microfine cement is most suitable. Microfine cement contains very finer particles than the ordinary Portland cement, so it can flow into very fine and deep cracks in quick time. Another is that we use cement to construct cement concrete roads, PCCP. So cement concrete roads are more famous or high standard roads which are stronger than all other types of roads. They are also called as rigid pavements because of their rigid nature. Concrete cement roads have long lifespan even without proper maintenance. Load-wise also, they are much capable than all other types. Another one is to manufacture precast members. Many precast members are made using cement as binding material. Cement concrete pipes are widely used as drain, pipes under culverts, and etc. Cement concrete brick masonry is more famous because of the size of the block, ease of construction, and strength. Water tanks and septic tanks are generally constructed by cement concrete rings. Many other things like garden seats, flower pots, dustbins, lampposts are manufactured using cement. In addition, cement are also used for aesthetic structures. Since nowadays, cement is available in many colors. This is done by adding coloring agent while manufacturing cement, but the percentage of coloring agents should be below 10%. Some of the coloring agents are iron oxide, which gives a red or brown, cobalt, which gives blue. The colored cement makes the structure beautiful without any painting. colored cements are generally used for flooring finishing, stair treads, window sill slabs, external wall, and many others. So to sum it up, cement composition can be altered to produce different types of cement. It can be type 1 to type 5 in order to serve various reasons for its use as discussed. Now let's move to the quality test on cement. Quality tests on cement are carried out to check the strength and quality of the cement used in construction. It helps to identify the usage of cement for different purposes based on its durability and performance. So the following tests are conducted on cement in the laboratory are as follows. So first we have the fineness test, consistency, setting time, strength, soundness, heat of hydration, tensile strength, and chemical composition test. In this unit, we will discuss setting time test. So what do we mean by setting of cement? So when cement is mixed with sufficient water, within 1 or 2 hours after the mixing, the sticky paste loses its fluidity. With a few hours after mixing, noticeable stiffening commences. So the setting is divided into 2 stages. So first we have the initial set and then the final set. Initial set is when the paste begins to stiffen. Initial setting time is the time lapse from the addition of water in the mix to initial set. Next is the final set. So final set is when the paste begins to harden and be able to sustain some loads. Initial setting time and final setting time can be determined by using BCAT apparatus in laboratory. So that's it for our construction material cement. So thank you class for listening. God bless and stay safe.